Hello everyone. Today we will talk about another topic structure which is a non-linear kind of data structure. That is today talking about trees are basically the non-linear data structure in which the data is arranged in some kind of hierarchical order. Like when we are talking about a real world tree, the root lies at the bottom, then it extends upwards through its trunk and through branches, and further the leaves and the fruits follow. Whereas when I am talking about the tree data structure, there is one root which is the base root of a tree, which has different edges that connects other nodes or the data elements, which are known as the child nodes to the parent node, which lies above the current level. And then at the nodes that are at the same level are known as the siblings, whereas those nodes which are at the terminal level, that means the last level, which do not extend further, are known as the leaves. So as you can see in this example, the root of the tree is A, B, C, D, E, F, H, I, J, K, L. All are the child nodes to parent node root node A. E, F are child node to parent B. H is the child node to parent C. I, J, K are the child nodes to parent D. I, J, K are the siblings. E, F, H, I, J, K all are siblings because they all lie at the same level. Now talking about the level starts from the root. The root is considered to be at the level 0. The other level is level 1, 2 and so on and so forth. Different terminologies that are used in the trees. So what is the degree of the nodes? When I am talking about the degree of the nodes, I am talking about the number of successors. That means how many successors or how many child nodes are there present in a particular tree for a particular node. Now degree of a tree tells me the degree of the node having the maximum degree. Like suppose in our example, if there is a node which has two child nodes, and then there is another node which is having three child nodes, and there is another node which is having five child nodes. So the degree of a node will be 2, 3 or 5, whereas the degree of the tree will be 5 because that is the maximum degree any node can have in that particular tree. Now what is a path? Path is the connecting edges between the source and the destination, and uh, the depth of the tree is the maximum level of the tree plus 1. So that is known as the depth. Is the binary tree where each parent node can have maximum 2 child nodes. That is known as a binary tree. That means any node, any tree where every parent node or every node can have either 0, 1 or 2 child nodes, that will be known as the binary tree. Tree, every node should have two child nodes except for the last node. For a complete binary tree to exist, every node must have 0, 1 or 2 child nodes plus all the levels except for the last level must be complete. By complete I mean that for any level n, the total number of nodes that should be present should be equal to 2 raised to the power n. That means if a node is existing at the 0 level, so there will be 2 raised to the power 0, that is one node will be present at the 0 level. At level 1, 2 raised to the power 1, that means 2 maximum nodes must be present. At the level 3, there must be 2 raised to the power 3, that means 8 maximum nodes must be existing. But this rule is not compulsory for the last level. Last level can have an exception for this rule. But the thing is, whenever I'm in the last level also, the completion of the nodes or the filling of the nodes must happen from the left nodes. Like the left subtree must be complete before we start to assign the nodes to the right subtree. Binary tree. Extended binary tree is a tree where any node can not have one child for any node. There cannot be one child node for any node. And that means in an extended binary tree, a node can have either 0 nodes or 2 nodes. The nodes that are having 0 nodes are known as the external nodes, and those nodes having 2 child nodes are known as the internal. Trees are represented in the memory. Representation of a tree is through an array. When I try to implement the nodes to array, then if a node is present at A, is present at an index position k, then the mm, left child will be present at k plus 1, and then the right child will be present 2k plus 1. That is the theory where how you proceeds with the storing of the tree nodes to the your subtree. In the array representation, we make use of two-way linked list where the forward and the backward links pointers are replaced by the left and the right pointers. So any node will have a data at the middle, and the both ends will have two pointers, one for the left subtree and the right subtree. As you can see in the example, this is the way how a tree can be represented in the memory using a link.